All right, what's going on, fourth period? We are wrapping up this little mini chapter here before spring breaks. This is another important video. I'm going to go over two things here, and then I'm going to, somewhere during the video, show you a picture of the first purchase that I purchased for my daughter who's being born this summer. I made my first purchase, so I'll show you that at some point. And I'll know if you watch the video if you can catch that or not. So we're going to talk about two things mathematically. We're talking about radicals this unit, okay? We need to talk about multiplying, dividing, and what comes with that is this concept that's super important every level called rationalizing the denominator. So we'll do that, and then we're going to skip over some of this exponent stuff because we've done it already, and I want to jump right into the final piece, which is solving equations. So without further ado, let's get after it. First thing is multiplying, okay? If you see something like this, all of our multiplication rules stay, so we still need to FOIL this out. 2 times 1, 2 times negative 5 on the square root of 3. Let's start there. 2 times 1 is 2. But 2 times negative 5 on the square root of 3, you actually multiply the 2 and the negative 5. You leave the radical alone because there's not another radical involved, so that's actually going to be a negative 10 on the square root of 3. That's the first piece. And now you know you have to FOIL, so now we do 4 on the square root of 3 times 1, which that's easy. 4 on the square root of 3. And then we do 4 on the square root of 3 times negative 5 on the square root of 3. Now let me slow down here, because for this last piece here, you're going to do 4 times negative 5, which gives us negative 20. But then you're going to do radical 3 times radical 3, which is radical 9. Which can simplify. So let's go ahead and simplify it. This is negative 20 multiplied by 3. Square root of 9 is 3. So then we'll have a 2 here. These are like terms. They both have a radical 3 attached, almost like it's a variable. So what is negative 10 radical 3 plus 4 radical 3? Negative 10 plus 4 is negative 6. And then minus 20 times 3, which is 60. So our final answer is whatever 2 minus 60 is, so negative 58 minus 6 on the square root of 3. Boom. That's the first problem. Crazy. You just got to be careful when you're multiplying radicals. So right here, root 2 minus root 3. We can't subtract those. That might as well say x minus y. Can't do that. But radical 2 minus radical 3 squared, we can do radical 2 minus radical 3 multiplied by radical 2 minus radical 3, and we can FOIL that. Okay? I challenge you to pause the video here, try to multiply it out, and then you'll see me do it. Radical 2 is square root of 4. Radical 2 times radical 3 is radical 6. Radical 3 times radical 2 is another radical 6. And radical 3 is radical 9. So radical 4, square root of 4 is a 2. Negative root 6 minus another root 6 is negative 2 root 6. And then the square root of 9 is 3. So my final answer, 2 plus 3 is 5, minus 2 on the square root of 6. And you cannot go any farther than that, everyone, because this is just a constant term. This has a radical on it. That's almost like a variable. You cannot combine those like terms. Okay? Next thing is this piece, rationalizing the denominator. Okay, so for this, let me give you this breakdown here. We don't like radicals in the bottom. So we don't like this right here. Okay? And so the way you take care of it, it's a mathematical process called rationalizing the denominator. Here's what you do, and then I'll let you try it again on the next one below it. You can actually multiply the top and the bottom by the bottom. Okay? And in particular, let me say that again. I guess I need to teach you a word first. Okay, these notes build up. So let me teach you a word. This word is called a conjugate. Conjugate, I know you're used to hearing that in Spanish or in foreign language, conjugating a verb, but in math it has a specific meaning, which is where you have two factors that are exactly the same apart from the positive or the negative. Take a look at that. 3 plus root 7 and 3 minus root 7, those are conjugates. Root 5 plus root 2, root 5 minus root 2, those are conjugates. So the way you rationalize the denominator is if you multiply both the numerator and the denominator by the conjugate of the denominator. We are going to multiply both the numerator and the denominator by the conjugate of the denominator. So I go and I look at what my denominator is. It's 4 plus the square root of 3. So I'm going to multiply the top by 4 minus root 3. I'm going to multiply the bottom by 4 minus root 3. Okay, why am I allowed to do that? Like, math is weird, right? I can just literally multiply something by something else only because it's the same. Because what I'm technically doing here is I'm multiplying that by 1. 4 minus root 3 divided by 4 minus root 3 is 1. So I'm allowed to do that. So what we would do now is what we just practiced above. It all connects. We would have to FOIL the top and FOIL the bottom. And when we FOIL the bottom, some really good stuff is going to happen, which is going to allow us to simplify, which is why we want to do this in the first place. So let's multiply this quickly. 2 times 4 is 8. 2 times negative square root of 3 is negative 2 on the square root of 3. Negative root 3 times 4 is negative 4 root 3. And negative root 3 times negative root 3 is positive root 9, which I'll just go ahead and write as a 3. That's on top. Now look what happens on the bottom. 4 times 4 is 16. 4 times negative root 3 is negative 4 on the square root of 3. And then negative 3 times root 3 times 4 is positive 4 root 3. Those are going to cancel, which is great. And then we have plus root 3 times negative root 3, which is negative square root of 9, which is negative 3. So our final answer here, we have to take the top first. I see this and this. Those are like terms. So that makes 11. And then I see these in the middle that are like terms. That's going to make negative 6 root 3. That's on the top. And on the bottom, it's just 16 minus 3, which is 13. This is our answer. This means this is the exact same thing as the original problem, but it has been rationalized. There are no longer square roots in the denominator. So we rationalized it. So I think you should try this one, and I'll set it up for you, but then you see what you think, and we'll talk about it more on Tuesday. We're going to practice these concepts. We would multiply the top, the numerator, by 4 plus root 15, and we would multiply the denominator by 4 plus root 15. See what you think, see what you get. We'll talk about this on Tuesday. Okay? But then the last piece that I wanted to show you is the solving equations piece. Okay? Radical equations. It's an equation that has a square root in it. Okay? And there's going to be a very simple way to solve this. You've been solving equations like this one since like 5th, 6th grade. 2x equals 6. So we divide by 2, x equals 3. You used division to kind of get x by itself. We've also solved equations like this, where you use subtraction to get x by itself. Well, now we're just going to use another concept. We see this equation that has a radical. We need to get rid of that radical, and here's how we get rid of it. You square it. A squared to the second power and a square root, they undo one another. Because remember, we talked about this the other day, that the square root of x is the same thing as x to the 1/2. So it makes sense that if we have a radical, we raise it to the second power, and that 2 and that 1/2, they cancel each other out. So just by simply raising this to the second power, this squared and that radical cancel, and we are left with 3x plus 4. But we have to balance our equation, and if you are going to square the entire left side of your equal sign, you have to square the right side of your equal sign as well. And now we can solve. It's kind of nice. So the idea of a radical equation is if you see a radical, you need to isolate it because it might not be by itself. So if you can isolate the radical, which means get it all alone, make sure it's the only thing on its side, then you just square both sides. Those are your 2 steps. I mean, then you just, solve from there. But those are the 3 steps. Let's take a look at one more, and then we'll pick up tomorrow. So perfect. Example 2. Here's the radical right there. We need to isolate it. We cannot square it like this because that 2 is over here, okay? But if we move the 2 to the other side, now we are ready to rock and roll. Now we can square this side and square this side to keep it balanced. It's a scale. And this squared and this square root cancel out, and we're 6 minus 3x equals 2 to the second power, which is 4. Boom, you're ready to rock and roll. We need to subtract 6 to cancel those out. Subtract 6 over here. So we have a negative 3x equals 4 minus 6. We're going to have a fraction answer. That's okay. Divide by negative 3. And x equals 2/3. Bang. Okay. We'll talk about some of these harder ones later. But for the basic video here, and I'm almost done, I'll show you what I bought for my future daughter. Solving radical equations. Go watch those examples again. But probably more importantly for this one, I want you to feel comfortable with this idea of rationalizing, which means you have to feel comfortable with foiling these radicals. So we are going to start class Tuesday with foiling radicals and rationalizing, and then we'll move into solving equations, and we're starting to wrap up this unit. Here's one more thing, because I know some of you might not have listened to me in class today. We have got to do the homeworks that I assign. We do not have much homework in this class. We have to watch a video on Monday and send me a message showing me that you watched it. And then we have to do the 1 textbook assignment from the week. Got to. The off-campus learning day, the Khan Academy, I only had 6 of you do it. That's a little less than half. I'm putting in the zeros in the grade book. I don't care about the zeros. I care about your learning, and it's not happening unless you practice the things that I ask you to practice. So lean in on that. I'm going to lean in on it more. I'm going to be talking to you. But hey, come and talk to me. Tell me why you didn't do something, and let's make a plan to get you back on track. Love you guys. Oh, forgot. Check these out. Bang, look how cute those things are. Come on now. The Nike Valiant Velcros, the pink. Let's get it. All right. Have a great day.